Okay, so going to unit 1.1, which is numbers, intervals, and inequalities. What I'm going to do, I'm going to discuss numbers on their own, intervals on their own, and inequalities on their own. So when dealing with numbers, basically you have to know that in mathematics, numbers consist of integers, rational numbers, and irrational numbers, and so forth. So the most important are obviously integers, rational numbers, and irrational numbers. So our integers are just sets of whole numbers which are both positive and negative. So you can go maybe, for example, -4, -3, 1, 2, 3, 4, etc. And then rational numbers are just numbers of the form a over b. So these are like fractional forms where a and b are both integers. And then irrational numbers are numbers which cannot be expressed as a over b. So they cannot be expressed as a fraction. For example, √3. So numbers like 1/2, 1/4, 3/4 all fall under rational numbers. And then √3, √5, and so forth generally fall under irrational numbers. Lastly, all numbers are part of a larger set of real numbers, and this is denoted by our r with a stroke over here. So those are called real numbers. So you mostly see this one a lot in WTW, and you just have to know that it means real numbers, which is like all numbers overall. Okay, so our real numbers basically run from -infinity to infinity. So everything else in between -infinity and infinity is a part of the real number set. Okay, moving on to intervals. So we have intervals notation, and we have our notation system, which I'm going to show you all the forms that it can take. So it can either be the first one, which is from a to b, but not inclusive of a and b. So x is a number which is greater than a but less than b. And when you are writing down on a number line, you're going to put an unshaded circle over here to show that a and b are both not included. Okay, and then we have a and b both included, so we show it by a box, by box brackets. So it's a, x being greater or equal to a, but less than or equal to b, and this is shown on the number line by shaded circles. And we can have an instance where we are including a but not including b, so it is represented like this: a box bracket on the a side and a normal bracket on the b side. Okay, so we're going to have x being greater or equal to a but less than b. So we're going to shade the circle on a side and leave the circle on b side open. The same where we can have a not being included but being b included, and this literally means x is greater than a but less than or equal to b. And on the number line, it's going to be a unshaded and b shaded. Okay, then we can have from a up until positive infinity, and both of them not included. When it comes to infinity, you actually can't include infinity because infinity is not a number. So for infinity, it's always not included. So this means x runs from a to infinity, but not including a and infinity. And on a number line system, it is shown like this. So it's just going to show an arrow that it is going to infinity. Okay, the sixth one, -infinity to b. So -infinity is always open as well. And in this particular case, b is also open. So it's our x being greater than -infinity. So any numbers between -infinity and b, but not including -infinity and b, are included in the set of x. So here you're going to show it with an open at b and then an arrow going towards -infinity. Okay, and then the last one is going to be -infinity to infinity. So both of them are obviously open because these are not real numbers. So our x basically is a set of all real numbers now, because negative infinity and infinity are not included. So this can just be shown by arrows going to negative infinity and an arrow going to infinity, or you can just write it as arrow with a stroke which shows real numbers. Okay, so lastly on inequalities, we're looking at inequalities, and with inequalities we're going to have rules. So one might ask, what is an inequality? So an inequality is just an equation, but instead of having an equal sign, you're going to have less than, greater than, or less than or equal to, greater than or equal to. So these are the symbols that we use when we're dealing with inequalities. We cannot use the equal sign, because if we use the equal sign, then it automatically becomes an equation. Okay, so the rules that should be followed when using inequalities. The first one, if A is less than B, then A plus C should be less than B plus C. And if A is less than B and C is less than D, then A plus C, the lower ones, will always be less than B plus D, the greater ones. Okay, and then another one, if A is less than B and C is greater than 0, then AC is less than BC. For example, if A is equal to 2 and B is equal to 3, then this one is satisfied. Our A is less than our B, since our 2 is less than 3. And then C greater than 0, we can take C, let's say C is equal to 4. Then you actually see that AC, which is equal to 2 times 4, which is 8. And BC, which is equal to 3 times 4, is equal to 12. Therefore, AC is less than BC. Okay, the fourth rule, if A is less than B and C is less than 0 now, then AC is greater than BC. So any number less than 0 is going to be negative, right? And a negative number, if you multiply in an inequality by a negative number, then the sign is going to be changed. So over here we had less than over here, and over here now we have greater than. So if A is less than B and C is less than 0, then AC is greater than BC. Okay, so I'm just going to use these numbers again to illustrate. So let's say A is equal to 2 and B is equal to 3 and C is equal to negative 4. We'll see that AC is equal to negative 8 and BC is equal to negative 12. And negative 8 is greater than negative 12, so your AC becomes greater than BC. Okay, the fifth one says if A is between 0 and B, then 1 over A is greater than 1 over B. So for this one, I'm still going to use these numbers. So A is equal to 2 and B is equal to 3. So this condition is satisfied. So 0 is greater than, so A, which is equal to 2, is greater than 0, but less than B, which is equal to 3. And if we say 1 over 2 and 1 over 3, actually see that 1 over 2 is greater than 1 over 3, and this is B and this is A. So you now put a greater than sign. So once you're looking at the inverse is 1 over, then the smaller number becomes the larger one. Okay, so now that we've gone through the theory, I'm going to look at a few questions. Okay, so the first question is solve and write your answers in interval notation. So we have negative 4 over 3 minus x being less than 0. So there are obviously many ways to do these calculations, but I'm just going to show you the simpler one. So it's negative 4 over 3 minus x being less than 0. So when you have an expression of x on the denominator and you're dealing with inequalities, obviously x can be greater than 3, hence we can have a negative on the denominator, which if we cross multiply, we change the sign. So to avoid that, what you're just going to do is multiply throughout by the square of that, because the square of that is always positive. Anything squared will be positive. So that will cancel that square, and then you have 3 minus x multiplied by -4 being less than 0, because it's 0 times a value which will always be 0. So that's becomes -12 plus 4x being less than 0, and then 4x being less than 12, and x, so we divide throughout by 4, and x is less than 3. So this is our solution, but then it says write your answers in interval notation. And in interval notation, what we're going to get is anything less than 3 up until 3, but 3 is not included. So we're going to have x being an element of -infinity up until 3. So -infinity is never included, and 3 in this particular case is not included. So this is how you show your solution. Okay, and then the second question says 2x minus 6 over 3x plus 9 greater or equal to 0. So with this one, we just do the same thing that I had explained over here. So it's 2x minus 6 over 3x plus 9. Then you can multiply by 3x plus 9 squared being less than or equal to 0 times 3x plus 9 squared. So this side will just remain a 0. Then this side, that cancels that. So you have 3x plus 9, 2x minus 6 less than or equal to 0. So you're going to have 6x squared minus 54 being greater than or equal to 0. And this, if we divide throughout by 6, we have x squared minus 9 greater or equal to 0. And this can be simplified to x plus 3, x minus 3 being greater or equal to 0. And when it comes to this one now, we have two factors. What you're going to do is plot a graph. So over here you see that it's a square. So a square, and then we have these points. So it's -3 and +3. So we have -3 and then 3. So our quadratic function is going to pass through these. So over here we check for the coefficient of x squared, which in this particular case is +1. And when it's positive, then our graph is going to be concave upwards. And if it's negative, then it's going to be concave downwards. So our graph is like this, and then we need to find our points where the graph is greater than or equal to 0. And then you find out that this whole side is greater than or equal to 0. That whole side is greater than or equal to 0. So how we're going to write it, it's going to be this part. So your x is to be less than or equal to -3, or your x is to be greater than or equal to 3. So these are the two solutions that we're going to have, and to write them in interval notation, and you have x being an element of, so it's -infinity, so anything less than -3 up until -3, and then -3 is included. And then union, so union just says or, so it's adding on. And then union, the box, so this one is also 3 is also included, so it's 3 to infinity. So everything from 3 up until infinity is also a solution. Okay, so I'm just going to add on to the other questions that we've already done. So you're still solving using graphs and writing answers in interval notation. So the question is x cubed plus 3x squared greater than 4x. Okay, so when you have a question like this, you would like to send everything to one side. So what we're going to do is x cubed plus 3x squared minus 4x being greater than 0. Then with this one, you can factor out x and then get x squared plus 3x minus 4 greater than 0. But then you do not cancel out x when you're dealing with inequalities. You do not like cancel out x and then divide throughout by x. So you keep it as it is, and then you factorize everything else. That you have x, and then x minus 1, then x plus 4 being greater than 0. Okay, so now that we have all the factors, just going to plot the graph of x cubed. So we're dealing with x cubed now, and since we have a positive over here, our coefficient is positive 1, we're going to plot our graph. Our cubic function is going to start off as concave downwards, since it has a positive over here. If it was a negative, then it will start off as concave upwards. So we need it to cross over at 0, and at negative 4, and at 1. Okay, so it's going to be like that. So that is our cubic function, and we're going to look for points where it's greater than 0. So I see that over there it's greater than 0, and from there onward it's greater than 0. So I actually see that our x can take values between negative 4 and 0, and or values of x greater than 1. And these to be written in interval notation, it's going to be x being an element of negative 4 to 0, union 1 to infinity. So that will be our solution. So basically I would advise to use the graph method for solving inequalities. Some other people might prefer the tabular, but then the tabular becomes a little bit confusing as compared to the graphical method. So the graphical method, I think, is the best method to use when you're dealing with inequalities and of higher degree from quadratic going upwards. So it's basically the same when we get to powers of x going from 4 going upwards. You're still just drawing. So when it's 4, you're just drawing. It's a double quadratic, and so forth. Okay, so moving on to unit 1.2, which is the absolute value. Okay, so an absolute value of any number x is denoted and defined by modulus of x. So these straight lines over here, they stand for modulus. So that is basically absolute value of x, and this is equal to either x if our x is greater or equal to 0, or negative x if x is less than 0. So basically it does, it turns all negative numbers into positive numbers. So if you had, let's say, if our x was negative 1, then it would be negative 1, giving us 1. Okay, so basically x is the distance from x to 0 on the number line. So on your number line, let's say that's your x, that's the 0, and let's say your x is equal to 5, or over the side, let's say that's your x, and your x is equal to negative 3. So our modulus will be this distance, which is 3. So distance can never be negative. That's why the modular sign, the absolute value, will always be positive. And over here, you have 5. So this will be a modulus of x. That will be a modulus of x as well. Okay, so you can get expressions like x minus a. So x minus a, modulus of x minus a is equal to x minus a if your x minus a is a positive, so greater or equal to 0, or negative x minus a if x minus a is less than 0. So if it's less than 0, then we're going to have a negative number in this bracket, and then it's going to be multiplied by a negative, giving us a positive. So it basically translates to x minus a if x is greater than or equal to a, or negative x minus a if x is less than a. So next on, we're going to look at the properties of the absolute value. So suppose a and b are real numbers and n is an integer. Then our first one, modulus, so absolute value of a and b is equal to absolute value of a times absolute value of b. And absolute value of a over b is equal to absolute of a over absolute value of b, whereby b is not equal to 0, because once it's equal to 0, then it's indeterminate. Okay, so the third one, modulus of a to the power of n is just equal to the absolute value of a then to the power of n. So you can take out the n to the, you can take out the power n outside the modulus function. Okay, and a squared, the square root of a squared is equal to modulus of a, because over here your a, where either it be a negative number or a positive number, it's always going to be positive due to this square, and then it's square, you get the root of that, so that it becomes only positive a. Okay, so some additional properties. So suppose a is greater than 0, then modulus of x is equal to a if and only if your x is equal to plus or minus a. And then the second one, modulus of x is less than a if and only if your x is greater than negative a but less than a. And modulus of x is greater than a if and only if x is greater than a, or also it's x greater than a and x less than negative a. So these three, you should take note of them because they will appear many times during the course. Moving on to the questions for Unit 1.2. Our first question says, write in the form of our function being equal to this if x is greater than or equal to, or that if x is less than etc. So the first one is modulus of 3 plus 6x. So we have modulus of 3 plus 6x. So this is definitely equal to 3 plus 6x if our 3 plus 6x is greater or equal to 0, or negative 3 plus 6x if 3 plus 6x is less than 0. So you can obviously simplify this part so that you can only be left with x as instructed by the question. So you can rewrite it as 3 plus 6x if x is greater or equal to negative 1 over 2, and 3 plus 6x, everything negative, if x is less than negative a half. I usually find out that most of the times these two will be the same. They have to be the same. Okay, so that is the solution for this particular problem. It's quite simple and straightforward, as you have just seen. And then the next one is x to the power 4 plus 4. So with this one, this is equal to x to the power 4 plus 4 if x to the power 4 plus 4 is greater than or equal to 0, and negative x to the power 4 plus 4 if x to the power 4 plus 4 is less than 0. but then you should note that x to the power of 4 will always be positive. So we are always going to have a positive value no matter what value of x we get. So this basically just goes to x to the power of 4 plus 4. So modulus of x to the power of 4 plus 4 is equal to x to the power of 4 plus 4, because this value will always be positive. Even if you put negative 2 to give you 16, positive 16. So this is not necessary. So we're only going to have x to the power of 4 plus 4. Okay, so for the next group of questions, we are asked to sketch the graphs of the following pairs of functions on different set of axes. Okay, so with this one, we are required to sketch on different sets of axes. So over here I'm going to plot g of x, and over there f of x. So I'm going to have f of x being equal to x plus 4, and f of x being equal to, and g of x being equal to modulus of, so it's absolute value of x plus 4. Okay, so over here I'm going to have 4, and over there I'm going to have negative 4. So my f of x being equal to x plus 4 would just be a straight line like that. Okay, and then coming to the absolute value, which is g of x. So as you can see over here on your f of x, is still greater than 0. So this part, it's positive. Only when it gets to this does it become negative. So I'm going to have 4 and negative 4. And then I'm still going to plot it until it gets to 4. So here we're supposed to, if it wasn't absolute value, it would have continued like that. But then it's absolute value, so it's just a reflection of this in the positive. So it would just be that. So that would be a graph of modulus x plus 4. And this one's just x plus 4. Okay, being equal to y. Okay, so I'm going to look at another one. So it's f of x being equal to 2 to the power of x, and g of x being equal to the modulus of 2 to the power of x. Okay, so for f of x, so when it becomes 2 to the power of 0, it's 1. So you see this one is only positive. So that's positive. It never goes down to the negative side. So when you ask to plot the modulus of 2 to the power of x, you're still going to draw the same graph as f of x. So it's just going to be, then there you're going to have your 1. So this will be your g of x. So the modulus sign, what it basically does, the absolute value, it makes everything that was negative positive. So if you had like a negative 1, you have a positive 1. If you have a negative 2, you have a positive 2, and so forth. So it's basically an easy function to use. Sorry about that. Basically an easy function to use, and you're just making everything positive. So whatever was negative becomes positive. What was positive remains positive. Okay, so for the next set of questions, we're going to have to solve using relevant theorems, and we're required to write our answers in interval notation. So the first question is modulus of, so it's absolute value of x minus 2 greater than 0. And according to our properties, we say if it's like this, then it has to be x minus 2 greater than positive 0, and x minus 2 less than negative 0. So negative 0 and positive 0 just equal to 0. So your x minus 2 is less than 0, is greater than 0, and x minus 2 is less than 0. For that to happen, our x is greater than 2, and x is less than 2. So any other numbers apart from 2 are viable answers. So basically x is not equal to 2. So x is an element of all real numbers. And in interval notation, x is an element of negative infinity up until 2, and then union from 2 to infinity. So this says everything is included apart from 2. So this is how you work a problem of this structure out. Okay, and then the next one says the absolute value of 2x being less than 7. So we say if it's less than, then it's 2x is less than positive 7 but greater than negative 7. Then x be negative 7 over 2 less than 7 over 2. So you can write that this one in interval notation as x an element of, so this is interval notation, then you can write it down in set notation as x an element of negative 7 over 2 to 7 over 2. So this is your interval notation. So in the previous example, in this one, our answer would have been x not equal to 2, because this also shows an interval, or you can use the set notation because it shows two intervals, that interval and that interval as well. So you can either write it as that or that. Okay, so this is how you can write your solutions. Okay, moving on to the third one. Says modulus of 3 minus 7x less than or equal to 6. So we said if it's less than, then it's 3 minus 7x less than or equal to positive 6, greater than or equal to negative 6. Then we can subtract 3 from both sides. That we have negative 7x. Then so we're subtracting, so it's minus 6 minus 3 becomes minus 9. And then 6 minus 3 becomes 3. And then now there is a negative sign over here. So we're going to divide throughout by negative 7. And when we divide by a negative number, then our signs are going to change. So we're going to have x, and this one becomes less than or equal to 9 over 7. And then over here it's going to be greater than or equal to negative 3 over 7. So rewritten can be x greater or equal to negative 3 over 7, and then 9 over 7. And then you can say x is an element of, so there is an equal sign, so there's inclusivity. So negative 3 over 7 up until 9 over 7, everything included. So that would be our final solution. So just please do remember that when you're dividing by a negative number, you have to change the signs. So lastly, we're going to solve this one. It's modulus of 2x over x minus 1 less than or equal to 0. So with this one, it's kind of tricky. So what you're going to do is notice that on the numerator, it's already modulus of 2x. So it will always be greater than 0. So that's a positive. So in order for it to be less than 0, in order for it to be negative, the denominator has to be negative. And for that to happen, x minus 1 has to be less than 0. And for that also to happen, x has to be less than 1. So when x is less than 1, then the denominator is going to be negative, and our numerator is going to be positive. Hence, we will have a negative number. Therefore, our x will be an element of negative infinity up until 1. So that will be our solution. So when you see a question like this one, you just have to think to see that the numerator is going to be positive, because if you try to work it out like normal equations, then you're going to be stuck. So just try to reason it out, and then you move on to your solution. So that's basically it from theme unit 1.1 to unit 1.2.